All right, so this problem requires us to find the area of the shaded region. But in order to do that, I'm actually going to start with the area of the non-shaded region. So to help you know what I'm talking about, I'm going to start by highlighting that area. So what I notice is that I have a triangle here that is the exact same as this triangle down here. And if I were to slide this triangle up, what would happen is I would actually have a parallelogram, because parallelograms are made up of two triangles. So notice what I did here. I simply took this triangle's area and I'm adding it to this triangle's area to create a parallelogram with the following measurements. I have 12 as my height times 4 as my base, and I know that 12 times 4 is 48. Now that still leaves me with these smaller triangles, but once again, if I take one smaller triangle and I add that area to the other identical smaller triangle, what I really have is a parallelogram with these dimensions. Area equals base times height. So I'm going to say area equals 2 times 6, which equals 12. Now, so far, I've only calculated the areas of the non-shaded white regions. So what I need to do is I need to put those together. So I have area equals 48 plus 12, which is going to give me 60 centimeters squared. Now, so I need to think to myself, okay, if that's the white area, how do I find the shaded area? And what I need to do is I need to actually find the area of the overall rectangle, and then I need to subtract. So to find the area of the overall rectangle, I need to do area equals base times height. So let's start with my base. Area equals 12 plus 2, which I know is 14, times my height, which is 4 plus 6, which is 10. This one we can do in our heads because it's a multiple of 10. I'm just going to add my 0 to 14, so area is going to be 140 centimeters, and once again, that is squared. So if that's my area of my overall shape, to find just the shaded area, I'm going to go 140 minus 60, which is 80 centimeters squared. Because we did so much work here, we definitely want to box our answer to distinguish it from the rest of our steps. All right, we're going to move on to lesson 7 now, which is where we start to think about the relationship between parallelograms and triangles. So it's going to be doing a lot of what we did in this previous problem, where we think about how our parallelograms actually made up of two triangles. So number 1 says to decompose. Let's talk about that word. Put a box around it. Decompose. Decompose we usually think of in science, like to break down. And in this case, it really means to break down or to break apart. So I'm just going to write here to break apart. To decompose or break apart a quadrilateral into two identical shapes. Claire drew a dashed line as shown in the diagram. She said that two resulting shapes have the same area. Do you agree? Explain your reasoning. Okay, so for this one, we're going to have to find the area of the two shapes, and then we're going to have to determine, are they the same? Let's start with my parallelogram. So I know that the area is base times height. So I know that area of my parallelogram is going to equal 2 times 4, which is going to equal 8. Then I'm left with a triangle. The area for a triangle is 1/2 base times height. The reason why it's 1/2 is that what I could do is I could draw another triangle right up here that's identical, and that would be base times height. But I only have half of that shape, so I need to do 1/2 base times height. So in this case, the area, and again, it's of my triangle, so just to distinguish it, next to the A, I like to draw a little triangle to show that this is my area of a triangle and it's not of a parallelogram. So in this case, area of my triangle is going to be 1/2 base times height. So it's 1/2 4 times 4, which is, let's draw parentheses here so that we know that we are multiplying, which is going to be 1/2 times 4 is the same as 4 divided by 2, which is 2 times 4, which is 8. So actually, are those two areas the same? Yes, they are. So off to the side, we can say yes. And then in terms of showing our reasoning, we've already done that by calculating the area of the two shapes. B, did Claire partition the figure into two identical shapes? The word identical means the same. So put a box around identical, and then off to the side of that, just write same. So I'm looking at these two shapes, and they're definitely not the same. One is a triangle, and one is a parallelogram. So my answer to this is going to be no. The two shapes are not identical because one is a triangle and one is a parallelogram. Two, triangle R is a right triangle. Now let's talk about what this means. A right triangle means that there is a right angle. So I'm going to draw that right angle with a box. Can we use two copies of triangle R to compose? Compose means to create a parallelogram that is not square. If so, explain or sketch a solution. If not, explain why not. So what I want to do is I want to think to myself, if I have a copy of R, which I have right here, two R's, when I put them together, is the parallelogram going to be square? Is it always going to result in a shape with four identical sides? Well, let's see. I know if I copy R and I move it here, like so, that results in a square. But do I always have to move it in that way to make a parallelogram? Here's some other options I have. I could move my R this way. And again, make sure you're drawing the shapes with me. And that's going to make a giant triangle, which is not a parallelogram. A parallelogram, remember, has to have two sets of parallel sides. Are there any other ways that I could move it to create a parallelogram? No. Any way I move it, I'm either going to be creating a square, I'm going to be creating a large triangle. So down here where it says, if so, explain how or sketch a solution, I actually can't do that. So I have to do the explain why not. So I'm going to say every time I move triangle R next to itself, I create either a larger triangle or a square. I cannot create a parallelogram that is not square. 3, we're going to play with some more triangles. 2 copies of this triangle are used to compose. What does compose mean again? Yes, create a parallelogram. Which parallelogram cannot be the result of the composition? If you get stuck, consider using tracing paper. So I will not be providing this to you, but we are going to be doing this together. So what we want to do for each of these problems is we want to think about how can I break this parallelogram into 2 identical triangles that look like this orange triangle. A, I can draw my line from this corner to this corner. And I know that each of those triangles, I can draw this just to prove it, each of those triangles that is identical. One, I've simply flipped across the line. So A can be made as a result of the composition. B, I can draw my line here. And once again, you'll notice that these 2 triangles are the same. One's been flipped. So B can be made with the composition. C, I can flip my triangles across, but I'm noticing that C and A look a little bit different. The reason for that is that this is a different triangle. How do I know? Because when I'm looking at the relationship, if I look at the smaller shape right here, I'm going to just switch pen colors so you can really see it. If I'm looking at this tip of my triangle, that is not the same as this tip and this tip and this tip. So what they've done with C is they've actually changed the dimensions of the triangle slightly to where it is a different triangle. So C is my only one that I cannot create using this orange triangle put together. 4, on the grid, draw at least 3 different quadrilaterals. So quad means 4. So it has to have 4 shapes that can each be decomposed. So again, that means taken apart into 2 identical, which means the same triangles with a single cut. Show the cut line. 1 or more of these quadrilaterals should have non-right angles. So non-right angles means that instead of being a square like this, the angles need to look more like acute or obtuse angles like this. Okay, let's do an example. So we're going to do 3 different quadrilaterals that can be decomposed. So I'm going to start here with a right angled one because I feel like that's a little bit easier. What if I went 2 by 4? And I know that I can split this into 2 identical triangles by drawing a cut line in the middle. So here's my cut line. And I know that the area of each of these triangles is half the area of my quadrilateral. I also want to draw in my base and my height. So my base here is 4. My height is 2. Okay, now let's try one that does not have right angles. So I'm going to start with my points. What if I were to connect this point? I'm going to do 1, 2, 3, 4, 5, 6. This point. And then if I were to count back 1 here and 1 here, I connect these lines like so. Oh, sorry, I'm actually going to use my line tool because I'm having a hard time. Like so, 1,